Hi, 8th grade. We're going to go over the notes for lesson 28 today, but I first want to show you this page right here. I emailed you a PDF and you also got a hard copy. So this one is for you to use for lessons 28, 29, and 30. So this will give you one page that has all of the important information for all of our Unit 5. So follow along on this one as well, or after we do notes every day, put the information on here as well so you have it in two spots, but this one will be easier to look at. So let's get started on lesson 28. So lesson 28 is all about scatter plots and association, which another word for that is correlation. We'll get to that in a second here. So it's looking at this problem that I'm going to let you read on your own, and it just asks a couple questions going through here. Like, what's the highest score? We're just going to look at the test score and find the highest one. The corresponding studying time is the study time that goes with it, 90. Lowest, same thing. We're going to look for the lowest score, which is right here at 35. The corresponding minutes is 30. So the approximate mean, I just want to review real quick. The mean is the average. So you add them all up and then divide by how many there are. So I got a mean of 73.6 and a mean of 65.2. Okay. So then are there any ordered pairs that are surprising to you? Well, maybe if you're just looking at this, it doesn't look that surprising, but once you start to look closer at this, or we'll see it in a graph later, this point right here seems a little bit surprising. Like, these guys are studying for quite a bit of time. This guy's even studying for, a decent amount of time, but he only gets a 38 on the test. That's kind of surprising. There's another name for a surprising point, and it is an outlier. So I would say that this point is probably an outlier, doesn't necessarily go with the rest of the data. Then it says, do you think that spending more time studying helped those students do better on the test? Why or why not? Well, I'm going to say yes, first of all, because I'm a teacher, and second of all, because, as you can see over here, if you study for longer, like 90 minutes or 99 minutes, you're going to get a really high score, like 100 or 99. If you don't study for as long, like 25 minutes, you might get a lower score, like 30. What this is saying is that there is an association. There is association. And since one is growing, like the bigger the minutes, the bigger the score, that's a positive association. And we'll do some more vocab on the back page right here. So a scatter plot is a graph of the ordered pairs. Ordered pairs are just the points, and it represents the table that we saw on the back page right there. So this is the graph of all of those points. Like I said, the outlier is the one that's kind of away from the rest of the data. You can kind of see that this stuff kind of goes in a line. This guy right here is that outlier. It says that the study of two related variables is called bivariate data analysis. We know that bi means two, like a bicycle, and variate is like variables. So bivariate means there's two variables. In our example right here, it's minutes is a variable and test score is a variable. Then I want to point out this word right here as well. This is quantitative data because both are numbers or quantities. We won't talk so much about qualitative data this year, but quantitative data is what we are going to focus on. Bivariate quantitative data. Two variables, both are numbers. So the focus of this lesson is talking about association. Like I said, association is also called correlation. And we might have a positive association, like we have right here, as studying increase, test scores increase, that's a positive association. You could also have a negative association. A negative association is if like one decreases, the other increases. So we can also see that this is a positive association because you can kind of tell that these dots from right to left are going uphill. That's a good indication that that's positive association. And then the last thing we have to talk about is linear versus nonlinear. Linear, we know, means a line. Nonlinear, not a line. This data right here, I'd say is roughly linear because it's pretty much a line. It's not like it goes up and down or does any W shapes, weird shapes. It's fairly linear data. Now, I want you to pause this video and I want you to type your answer to this in the comment section on this video right here. So is it surprising that there's a positive association between the variables in Mr. Finley's data set rather than a negative association? Why or why not? Think about these these lines right here. What does it mean for a positive association? What does it mean for a negative association? All right, moving on, we've got the next page, identifying positive and negative associations. So this is just more information on how you can tell if it's positive or negative association. So Mr. Finley was wondering if there was a relationship between the number of texts that students sent the day before the final exam and their test scores. He asked students to volunteer the data from their cell phones, and he compared it against their test scores. How can he identify trends? Well, now we've got the number of texts and the score on the test. Again, this is bivariate data because there's two variables, and it is quantitative data because it is, qualitative data, I'm sorry, because they're both numbers. So, we are looking at the scatter plot of these points that are all plotted. And the book here actually drew in a line for the mean number of texts, that's again where you add them all up and divide by how many there are, and the mean score on the test, which is when you add them all up and divide by how many there are. The reason that they divide this up is because now it sometimes is kind of hard to see if it's going uphill or downhill. Now it's very obvious. It starts in the upper right or upper left and ends in the lower right. That's downhill. We can also see it by just chunking up into horizontal strips like this. Now you can see in this strip, this point or this arrow right here is this arrow right here is the middle of all of these data points. This is the middle of these data points, the middle of these data points, the middle of these ones. And you can see that these middles are going downhill, just like this data is going downhill. Since it's going downhill, that is a negative association. I'll let you read through all these ones on your own, but I do want to draw your attention to this one right here that's got the clouds on it and everything. The easiest way to tell if a scatter plot has positive or negative trend or association or correlation is by looking at its slope. We know that uphill, right to left, is a positive slope, and downhill, left to right, is a negative slope. That's the easiest way to tell if it's positive or negative. So now I want you to pause the video again and type your answer to this question right here, also in the comment section of this video. So describe a situation where a negative association would exist between two variables. Explain why you would expect it to be a negative association. And we're going to just take out this one right here. I just want you to give me an example of something that has negative association. Okay, so one thing where as something increases, the other thing decreases. Now I do want to go over these guided practice questions with you as well, kind of as examples. And then the next day you're going to work on your own homework, and then you'll get one more homework assignment on this one. So I'm going to skip over the example. I'll leave it there for you to read if you would like. Let's start right here. Do you think that Mr. Finley should encourage students to study algebra on the website mentioned in the introduction or on this new website? So Mr. Finley tries a new website for studying, and this is his correlation. These points are all over the place. There's no downhill, there's no uphill, there's no association right here. That means that it doesn't matter if you study on this website, it's not going to help your test score. If we look at the introduction, which is this one right here, we found that the longer that you studied, the better your test score. So which one is going to actually help you study? The one from the introduction. We're going to look at the quadrants on the graph on the previous page. What percent of the points fall in each of the four quadrants? What do these percentages tell you about the association between the two variables? So we're going to go over here, and we're going to find what percentage of the dots are in each quadrant. So there's 1, 2, 3, 4 right here. 1, 2, 3, 2, 3, 4, 1, 2, 3, 4. Okay, so altogether that is, let's see, 15. And there's 4 out of 15 in several of them, and there's 3 out of 15 in one of them. So I'm going to go back over here. So to find the percentage, let's see, 4 out of 15, I'm just going to divide those. I'll use my calculator. 4 divided by 15, 0.26 approximately, so I'm going to say about 26.7% in 3 different quadrants, and the other one was 3 out of 15, so I'm just going to divide to find that percentage. 0.2, so that's 20%. There's not really a lot more in any one of the quadrants, so that means there's no association. Since they're pretty evenly spread, there's about 20 to 25% in all 4 quadrants. There's no association. It's not like there's more up here and more down here. It's just nothing. Okay. Which pair of variables would you expect to have a negative association? So remember, a negative is like as one goes up, the other goes down. So the amount of money you make in a week and the number of hours you work during the week. Well, let's think. If you work more hours, do you make more money or less money? More money. That's positive. A person's height and the number of pets he or she owns. So if you're taller, do you think you own more pets? I don't know. I think this one's a no association. Those don't really relate to each other at all. The speed at which a person drives to work and the time it takes her to get to work. So if I'm driving 50 miles per hour, that's going to take me a little bit longer than if I'm driving, let's say, 100 miles per hour, which nobody should be doing, but it's going to get you there faster. So the bigger your speed, the smaller your time. That is negative. Now let's just double check right here. The number of friends you have and the number of birthday parties you attend in a year. So if you have more friends, do you think you're going to have more or less birthday parties? Probably more, because you got more friends that will invite you. So I would say that C is the best answer here. I'm going to skip over this one too, just for time. So those are your notes for lesson 28.